Hello, precious one. I welcome you once again into Kenya Mathematics Classroom. On this particular episode, we are going to look at the continuation of rational functions. In our previous presentation, that's the part 2 of the rational functions. We have explained in general what you call the partial fractions and the types that we have. We said that we have denominators with a linear factor, we have denominators with a repeated factor, denominators with a quadratic factor, and that of the improper fractions. We said that with the denominator with a linear factor, the quadratic factor, the repeated factor, they are all proper rational functions. And we also have the fourth type, and that is the improper rational functions. Now, with the improper, we are saying that when the degree of the numerator is equal or greater than the degree of the denominator, then we say it's an improper fraction. Now, these are the questions we are going to see how best we can solve them. These are the questions we are given to solve. Now we are asked to express the following as partial fractions. And so let's see how best we can solve these problems. The first question, we are given 3x plus 7 over, we have x minus 1, then we have x plus 4. So what we do is, when we are given the question, you check whether it is proper or improper. You check whether it is proper or improper. Then when you check and it is proper, then it means it is either denominator is the linear factor, that of the quadratic factor, or that of the repeated factor. Now, why do we say this is a linear, is a proper rational function? The degree of the numerator is 1. The degree is the highest exponent of the variable. And the degree here is 1. Now, the degree here, when you look at the denominator, the degree here is 1. The degree here is also 1. But when we multiply, there will be a quadratic expression. And so that means that the degree of the numerator is 1, that of the denominator is 2. So this is proper because the numerator is less than that of the denominator. So this is a proper rational function. Now, when you determine and you realize that it's a proper rational function, then we now look at the denominator, the factors, to see are they linear factors, repeated factors, or quadratic factors, or that is the three. So we have linear, we have repeated, and we have the quadratic. Now, when you look at this, we are saying that for it to be quadratic factors, they must be expressed in the form ax plus b. That's the degree of each of the factors must be 1. You can see that here the degree is 1, here the degree is 1. So all the two factors we are given are in linear form. And so this is going to be 3x plus 7 over x minus 1. Then we have x plus 4. This will be equal to a over the first factor, that is x minus 1, plus b over the second linear factor, that is x plus 4. Then a step down, we have 3x plus 7 over x minus 1. We have x plus 4. Then we find the LCM. The LCM will be the same thing. So we have x minus 1. Then we have x plus 4. So this here, we are left with this. And that's x plus 4 times a. So we are going to have a times x plus 4. Then we have b times, because this here we are left with this. So b will multiply x minus 1. So we have x minus 1. Now, take note. There is something I want to show you here. If you have x over 2 is equal to 7 over 2, you can say that because the denominators are the same, then the numerators can be equated to the other. So because 2 is 2 here, then you can say that x is equal to 7. Or better still, you can cross multiply to see. Now x times 2 will give us 2x. Then 2 times 7 will give us 14. So if you want to find x divided by 2 divided by 2, then it means x will be 2 goes into 14 7 times. So you still get the same 7 I'm talking about. So when the denominators are the same, you can equate the numerators. That's what I'm saying. So back here with the same idea, then we can also say that because the denominators are the same on the left and the right, then we can equate the numerators. And so here we have 3x plus 7. Up here we have a times x plus 4 plus b times x minus 1. And this is our identity. Now we are going to solve for a and b. So what we do is we are going to put x to be equal to some values in such a way that one of the variable will be, one of the alphabet will be eliminated so that we can find the other. Now when you look at this identity, you realize that 3x plus 7 equals a into bracket x plus 4 plus b into bracket x minus 1. When you put x equals 1, then 1 minus 1 here will give us 0. So 0 times b will be gone so that we can find a. So first we say put x is equal to 1. And we know why we are doing that, and that's what I've explained. So wherever you see x, you now substitute it by 1. So we have 3 times 1 plus 7. This is equal to a, then 1 plus 4 plus b. This should be 1 minus 1. And 1 minus 1 is 0. So 0 times b. B is now out of the equation. Now 3 times 1 is 3 plus 7 is 10. So we have 10 on the left hand side. The right hand side here, 1 plus 4 is 5. 5 times a is 5a. Is 5a. Don't forget that the b is no more because 1 minus 1 is 0. 0 times b is gone. So here we divide both sides by 5. Then a will now be equal to 5 into 10 is 2 times. So the value of a is 2. The value of a is 2. Then you write the identity back. The identity, we have 3x plus 7 is equal to a x plus 4 x plus 4 plus b x minus 1. So first we said that x should be equal to 1 and we are able to find a. Now when we look at the equation again, we realize that when we put x to be equal to minus 4, then if x is minus 4, then minus 4 plus 4 will also give us 0. 0 times a, then a will be gone. Then you can also find the b. So when you put x equals minus 4, then we are going to have 3 times minus 4 here plus 7. This is equal to a into bracket minus 4 plus 4, then plus b into bracket. We have minus 4 minus 1. Okay, so 3 times minus 4 give us minus 12 plus 7 is equal to, then this should be a times 0. So a will be gone. Then we have b minus 4 minus 1 is minus 5. Okay, so minus 12 plus 7 will give us minus 5. And this is equal to a is gone. So we have minus 5b. And we are solving for b. So we have to divide it by whatever is attached to that b. So we divide by minus 5 minus 5. And the b will be equal to minus 5 or minus 5 will be equal to 1. So you can see that b is now equals to 1 and a equals 2. So it means that wherever you see a, then a is now 2. So it will be 2 over x minus 1. Then plus b, and b is 1. So plus 1 over x plus 4. And that will be the solution to the first part of the question. So that is how we solve the denominators with the linear factors. That's how we solve the denominators with linear factors. Denominators with linear factors. So we had a to be equal to 2 and b to be equal to 1. So when you are done with that, in partial fraction, finally you say that then whatever you were given, which was a over x minus 1, a is now 2. So you write that 2 over x minus 1 plus b is now 1. So that is 1 over x plus 4. X plus 4. So this is what we call the partial fraction. This is what we call the partial fraction. Don't forget that when you are done solving for a and b, you have to take it back. Wherever you see the a, you put it there. Wherever you see the b, you put the value there. And that will be the partial fraction we are talking about. So in general, that is how we solve expressions like that. So take note of that. This one, you are only putting x in, so you have to look at the identity yourself and find out the values that when you put in there, one of the alphabet to be eliminated so that you can find the other in that order. So this, as you work a lot of examples, you understand what we are talking about in general. So take note of that. And now let's continue to see how best we can solve the second question. I advise that if you are not okay with what you have on the board, you take your time, take the video back because you are in charge. You can take it back, take your time, get your book, get your pen, get your calculator, and begin to follow, and you understand everything. Now we continue. The second question, we have the second question up there. And with the second question, we are asked to find, or we are asked to solve for, 3 minus 2x, that is 3 minus 2x over x minus 2. Then we have x plus 2. X minus 2, then x plus 2. Okay, so when we look at this, check whether it is proper or improper. The degree of the numerator is 1, but the degree of the denominator, 1 will be here, 1 here. So we are going to have a quadratic expression. So it means that 1 over 2 is proper. Then if it is proper, now let's check whether it's a linear factor, quadratic, or repeated. This factor can be expressed in the form ax plus b. That is how it has been expressed. the degree is 1. So these are linear factors. So quickly, we know that if it's a linear factor, how do we solve it? It will be 3 minus 2x over x minus 2 x plus 2. This should be equal to a over the first factor is x minus 2 plus b over the second factor is x plus 2. So we now simplify as we solve the first one. Then we have x minus 2, we have x plus 2. We find the least common denominator. Then we have x minus 2 here. Then we have x plus 2. That's the least common denominator. So this here, we are left with this. And this times a will be a times x plus 2. Plus this here, we are left with this. And this will be multiplied by the b. So we have b times, we have x minus 2. So we simplify. Now we can also see that the denominators are the same on the left and the right. So we can equate the numerator. So we have 3 minus 2x equals a. We have x plus 2 plus b. Then we have x minus 2. So here you also have to look at the expression and put in values of x that can eliminate one of the alphabet and you can find the other. When you look at this, you realize that when you put x to be equal to 2, then 2 minus 2 is 0. So b will be gone. Then we can find this. So let's simplify. Then we are going to have 3 minus 2 times 2 equals a. X is now 2, so 2 plus 2 plus b. Don't forget that this should be 0 because x is now 2, so 2 minus 2 is 0 times b. So we are going to have 3 minus 2 times 2 is 4, so 3 minus 4. So we have 3 minus 4, and that is minus 1, and this is equal to, this 2 plus 2 is 4. 4 times a will be 4a. So if you want to find a, divide by 4, this is gone. Then the value of a will be minus 1 on 4. Okay, so you write the identity again. That is 3 minus 2x equals a into bracket x plus 2 plus b into bracket x minus 2. So first, we said that x should be equal to 2, and we are able to find a. So now when you look at this, you also realize that when you put x equals minus 2, the minus 2 plus 2 also give us 0. So a will be gone. Then we can also find b. Okay, so we now put x equals minus 2. In doing that, you are going to have 3 minus 2 times x, and that is minus 2 equals a into bracket minus 2 plus 2, then plus b into bracket minus 2 minus 2 minus 2. Okay, so this should be 3 minus 2 times minus 2 will be plus 4, and this will be a times minus 2 plus 2 will be 0. Then we have b minus 2 is minus 4. So we are going to have 7 equals a is gone. Then this is minus 4b. So we divide by minus 4. We divide by minus 4, and this is gone. And the value of b will be minus 7 over 4. So take note that a equals minus 1 over 4, and b is minus 7 over 4. So a is minus 1 over 4, and b is minus 7 over 4. So in general, wherever we see the a, then we bring the minus 1 over 4 there. Then wherever we see the b, then we also substitute the minus 7 over 4 there. And whatever we have is what we call the partial fraction. So in general, that is how we solve the second part of the question. So you see that the first and the second part of the question, they are all denominators with a linear factor. They are all denominators with a linear factor. So we are now going to see how best we can solve the third question and the fourth question. So that is how we solve for that. Now when you get the a and the b, then you take it back into the expression. Wherever you see the a, you take it back. Wherever you see the b, you take it back. And you simplify, and that will be all. So we now see how best we can solve the third question. So I'll take this off. I also advise that you take your time, take the video back because we're in charge, and just listen to what I've been saying so far, and you understand exactly what we have on the board. If there's anything you don't understand, you can send it in the comment section. I will look at it, I'll read it, and I will explain or answer on this particular platform. Now we are going to look at how best we can solve the third one, the third question. Let's see how best we can solve the third question. Now, with the third question, you also check to see whether it's a repeated factor, whether it's a proper or improper. Now, the third one is 5x squared. The third one is 5x squared minus 3x plus 4 on x minus 2, then x squared plus 1. No, x squared plus 2. Okay, this is what we are given. Now, what you have to do is that you have to check whether it's a proper rational function or improper. Now, the numerator, you realize that the degree is 2. The quadratic expression is 2. Now, with the denominator, we have x exponent 1 here, x exponent 2 here. So, when you simplify, you get a cubic function. So, 2 over 3 is still proper. And therefore, we now check the denominator to see whether it's a linear factor, quadratic, or repeated. But when you check the factors, x minus 2 is a linear factor, but the x squared plus 2 is a quadratic factor. So because one of the factors is quadratic, then that would be the type 2. That denominator is a quadratic factor. And so this would be equal to a over the linear factor, that is x minus 2, but the quadratic factor would be bx plus c over x squared plus 2. So when you refer to the part 2 of this presentation, you understand why it's bx plus c, because I've already explained that if it's a quadratic. So if it's linear, if one of the factors is quadratic, then it is denominator is a quadratic factor. So it is a over x minus 2 plus bx plus c over the quadratic factor. So we now simplify. Then we are going to have 5x squared minus 3x plus 4 over x minus 2. Then we have x squared plus 2. This we find the least common denominator, then it's going to be x minus 2, then x squared plus 2. So here we are left with this. So a will multiply x squared plus 2 plus, then this here we are left with this. Then it means that bx plus c must be put in bracket, and that will multiply x minus 2. So you can also see that the denominators are the same. The denominators are the same, so we can equate the numerators. And the numerator on the left is 5x squared minus 3x plus 4. This is equal to a into bracket, we have x squared plus 2 plus b x plus c in bracket, then we have x minus 2. So we are now going to solve for a, b, and c. Then you realize that with these one, when you put x to be equal to 2, then 2 minus 2 will be 0, so that the whole of b and c is gone, so you can find a. So let's do that. And I advise that you solve a lot of questions so that you get experience in what I'm doing. Now you put x to be equal to 2. By substitution, we have 5 into bracket 2 squared, 3 times 2 plus 4. This should be equal to a into bracket 2 squared plus 2 plus this will be b times 2. Take note that is bx, so b times 2 plus c. Then 2 minus 2, but this will be gone because 2 minus 2 will be 0. So the whole of that expression is gone. So 5 squared, 2 squared will be 4. And 4 times 5 will give us 20 here. 3 times 2, we have 6 here, plus 4. This is equal to 2 squared is 4. 4 plus 2 is 6. So we are going to have 6a on the left-hand side. Now 20 minus 6 will give us 14 here. And 14 plus 4 will give us 18 here. So we have 18 is equal to 6a. And take note of this. If 18 is equal to 6a, then divide by 6, divide by 6. You can say that a is equal to 3. You can say that a is equal to 3. You can say that a is equal to 3. So let me get this off because for now we have solved the first part. We have solved the second part and we are on the third part. Okay, so the same expression again. We have 5x squared minus 3x plus 4 equals a. We have x squared plus 2 plus. We have bx plus c. Then we have x minus 2. So first we said that x should be equal to 2 and we are able to find the value of a to be 3. And now what we do is we are going to find another value. But now when we put, take note of this, when we put x to be equal to 0, you realize that 0 times b will be 0. Then we are left with c C and A, but because the A is known, then we can also find the C. And this is how we solve the denominator to the quadratic factor. So you look at it. Now put x to be 0. Then we are going to have 5 times 0 squared minus 3 times 0 plus 4. This will be equal to A into bracket 0 squared plus 2 plus this B times 0 plus C. Then this is 0 minus 2. 0, 0. This is gone. We have 4 left. 0 squared is 0 plus 2. 2 times A is 2A. Then plus B is gone because B times 0 is 0. Then we are left with only C there. 0 times 0 minus 2 is minus 2. So we have minus 2 there. Okay, so we have 4 equals 2A minus 2C. 2A minus 2C. Now we can have 2C on the left. Then we have 2A on the right. Then this should be minus 4 on the right hand side. So we have 2C here. 2A. Don't forget that A is 3. So we have 3 minus 4. 2C will be equal to 2 times 3 is 6. And 6 minus 4 will give us 2. So 2C equals 2. When we divide both sides by 2, then C is now giving us 1. So we have A to be equal to 3. Then we have C to be equal to 1. So you write the same identity again. Then you can put X to be any number at all, because now you know the value of A to be 3 and you know the value of C to be 1. So when you write the identity, you now put X to be equal to, it can be 1, it can be 3, it can be 4. Then you express it because you are given A, wherever you see A, you now put 3. Because you now know C, wherever you see C, you now put 1. And the value of B will be out. And so that is how we solve questions like that. That is how we solve questions like that. So let me come back here. So I advise that you take your time, get a book, get your calculator, get your pen, and begin to work it so that you can follow what I'm doing. You can follow what I'm doing. So with the same identity again, the identity is 5x squared minus 3x plus 4 is equal to A, we have x squared plus 2 plus bx plus c, and we have x minus 2. It's the same expression we are using. So now we can say that put x is equal to 1. It can be 1. So then we have 1 square is 1. 1 times 5 is 5. Then minus 3 times 1 is 3. Then plus 4. 1 square is 1. 1 plus 2 is 3. 3 times A is 3A. Then we have B times 1 is B. Then we have plus C. Then 1 times 1 minus 2 is minus 1. Okay. So 5 minus 3 is 2. 2 plus 4. This is 6 on the left. Then we have 3A. And don't forget that the A is now 3. So it is 3 times 3. Plus we have B. B is not known. B is not known. But C is known. C is 1. So we have plus 1. Take note that we are multiplying by minus 1. We are multiplying by minus 1. Okay, so we simplify. We have 6 on the left. 3 times 3 will give us 9 here. The minus 1 times B will give us minus B. Minus 1 times minus 1 will give us minus 1. So the B minus B can be on the left. So minus B on the left becomes positive B. And this will be equal to 9 on the left. 9 minus 1 will be 8 on the right hand side. Then we have minus 6. And 8 minus 6 is 2. So you can see that B is equal to 2. Don't forget that the A gave us 3. And the C gave us 1. And the C gave us 1. So if you remember, then when we go back to the expression, now we can see that A equals 3, C equals 1, and now B is equal to 2. So we have all. Now take note that we now have all the variables. So we can take it back to the equation. We can take it back to the equation. And whatever we have is what we call the denominator with a quadratic factor. So don't forget that it was 5x squared minus 3x plus 4 over it was x minus 2, then x squared plus 2. And we said that this should be A over, and now the A is 3. So it is 3 over x minus 2 plus bx plus c. And that b is now 2. So it is 2x plus c plus 1 over the quadratic factor x squared plus 2. So this is what we call the partial fraction. Remember that this was the question, and this is how it was expressed. A over x minus 2. A is now 3 plus bx plus c, and b is now 2. So we say 2x plus c, and c is now 1 over the quadratic factor. So b is the partial fraction. B is the partial fraction. Now, the fourth question is 5x plus 4 over x minus 1, x plus 2 all squared. So you can see that this is denominator with a repeated factor. So we will solve these questions in our next presentation. So I will advise that you check the next part of this particular presentation so that you understand how to solve this particular problem and other problems in improper fractions as well. But that will be all for now on this particular episode. Thank you.